Assalamualaikum warahmatullahi wabarakatuh. Thank you for coming to this presentation. I am glad to see you all. Let me introduce myself. My name is Liparar Panaputra, NRP 56. The purpose of my presentation is presented the final project about is planning of inspection schedule in pipeline transport in methane gas distributor using risk-based inspection method. Introduction. First, background. Second, problem and purpose. Third, advantage. 4, scope. 5, flowchart. 6, calculation. 7, conclusion and recommendation. In the next slide, background. Pipeline. Pipes are vital objects when distributing gas. Pipes that are flammable with natural gas that can be flammable, so that it is a danger to the environment around the pipe if damage occurs in the pipeline. Second, failure system. Regarding the corrosion process in pipelines is a very important topic. Third, relate event. This was proven in 2015 that a fire had occurred in the pipeline from the collecting station to the production storage center due to corrosion. 4. Method. RBI is a method for determining inspection plans for equipment failure problem. Next, problem background. First, how is the probability of failure in the pipeline distribution of methane gas Gresik offtake to the Gresik industrial area using the RBI method? Second, how is the consequence of the area affected by the failure of the methane from the Gresik offtake to the Gresik industrial area using the RBI method? Third, how is the remaining life in the methane gas distribution pipeline from Gresik industrial area? Fourth, how to plan the appropriate inspection procedure on the methane gas distribution pipeline from the Gresik offtake to the Gresik industrial area using the RBI method. Next slide, purpose. First, determine the probability of failure in the methane gas distribution pipeline from the Gresik offtake to the Gresik industrial area using the RBI method. Second, determine the consequence of the area affected by the failure of the methane gas distribution pipeline from the Gresik offtake to the Gresik industrial area using the RBI method. Third, determine the remaining life in the methane gas distribution pipeline. 4. Determining the planning of inspection procedure on the methane gas distribution pipeline. Then, advantage of research. First, being able to know the chance of failure in the damage factor. Second, being able to know the consequence of the area affected by failure. Third, being able to know the remaining life in the pipeline. Fourth, being able to determining the planning of inspection procedure on pipeline. The next slide, scope of problem. Location. The study was carried out on the gas distribution pipeline from Gresik offtake to KIG. Pipeline of failure. Failure of the pipe itself is not considered. Analysis. The cause of damage to the distribution pipeline are analyzed only due to corrosion and mechanical. Next, calculation of consequence. Calculation of the consequence of failure use is level 1. Scenario of failure. The failure scenario is a leakage scenario in the methane gas pipeline. Standard determination of inspection plans based on the RBI recommended practice 581, 580, 570 API. The next slide, flowchart. Start, and then in the identification problem, determining formulation, purpose, and benefit research. Collect the data. Primary data, interview expert judgment. Secondary data, specification, pipe, condition operational, result, inspection, layout, location. The next, measure preventive with method RBI, calculation probability of failure, and calculation consequence of failure. And the next, calculation of consequence financial and calculation of consequence area. Then, determining risk matrix, analysis risk matrix, determining remaining life, the plan schedule inspection, and last conclusion and recommendation. In the next slide. Next, it is the calculation of probability of failure. The pipe thickness has been determined as shown in the table. In the next slide, we can see the result of wall loss fraction calculation in the zone 4 has the biggest result. Next is calculate flow stress to get the conservative result at design temperature using this. After that, we can see the result of strength ratio parameter in the zone 4 has the biggest result. To determine the effectiveness category of the inspection using the formula, the fourth power is obtained from the number of these inspections that have been carried out. Then we can see the result of posterior probability. In the next slide, the result of the make factor can be seen in the following table. And then the final result of probability of failure is shown in the table. Next, to determine level consequence of failure, the calculation is used based on the table 2.5. This fluid belongs to group C1, C2 with the following properties: molecular weight 23, normal boiling point minus 193, ambient state gas AIT 1036 Fahrenheit, and liquid density 15.639. In the next, we can see the result of rate of leakage calculation. The same value is caused the same pipeline. After that, the result of mass available calculation is shown in the slide. Next, the result of type of leakage calculation is shown in the table. If the release hole size is on 0.25 inch or less, then the release type is continuous. If the value is less than equal to 180 seconds and the release mass is greater than 10,000 lbs, then the release is instantaneous. After that, the result of assess the influence of detection and isolation is shown in the table. And then the result of the calculation rate of leakage and mass of leakage is shown in the table. In the next slide, the result of total area consequence of leakage calculation is shown in the table. And then we can see result the level of loss cost is shown in the table. Then the result of risk matrix area effect get a risk value of 3C. It is medium level. Then the result of risk matrix financial get the highest value of 4C. It is medium level. In the next slide, the result of remaining life calculation is amount to until 4 years due to the age of the pipe has exceeded. After that, the result of inspection interval based on remaining life is shown in the table. Is caused by the corrosion rate is quite large and the age of the pipe is too. In the next slide, conclusion. Based on the result of calculation and data analysis, the following conclusion can be drawn. First, based on the analysis of the level of risk using the RPI method, the probability of failure value has a value of 2.42 E minus 03 failure year for zone 4. For zone 1 and 2 for 2.23 E minus 03 failure per year, and zones 3 and 5 for 2.06 E minus 03 failure per year. This is due to the age of the pipe, which is 20 years, which result in a large probability of failure value. Second, based on the analysis of the level of risk using the RPI method, the greatest value of consequence of failure is 2793.107 fit in zone 5. Thus, the risk value obtained from 5 pipeline zones is 3C or medium level. Third, remaining life of the pipeline based on calculation from the API 570 standard is still in a condition of about 2 to 4 years. This is because the pipeline has been operating for around 20 years. 4. The next inspection time of each pipeline zone based on the level of risk is 1 year to 2 years with a non-destructive test inspection method, namely visual and ultrasonic test. The last slide, the recommendation that can be given for future results include: first, making leak detection device such as ball valves that can close automatic if a leak occurs in the pipeline. 2. Making software or application to simplify inspection scheduling and integrate inspection program into software. And third, it is better if the effectiveness of the inspection done is more enhanced. This is because with a more effective inspection, the risk can be reduced. Okay, thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.